So in this video, I want to go over what the domain and range of each of the six and the graphs of each of the six trig functions look like. So we've been doing a lot of problems with sine and cosine. So the sine, the domain on the sine graph is from minus infinity to infinity. So it's all real numbers. The sine graph here goes all the way from the left and it keeps going on and on to the right. And then the range is from minus 1 to 1. So it's all the numbers between -1 and 1. And those same things hold for the cosine function. So the domain of the cosine function is minus infinity to infinity. And the range is also minus 1 to 1. It's when we get to the other trig functions that we have to work harder to be able to say what the domain, what the range is. So let's look at the tangent. Something that's not exactly clear on this graph here is that at these places here, at minus pi over 2, at pi over 2, at this would be over here 3 pi over 2, we have these vertical asymptotes. And so at that vertical asymptote, the function is not defined. And these are all the odd multiples of pi over 2. So the domain on the tangent is all values, so all real numbers, except the odd multiples of pi over 2. And then the range here, so my function, each of these pieces goes from all the way down here, it's going all the way down to minus infinity, and it's going all the way up to positive infinity. So you can write it either as minus infinity to infinity, or you could write it as all real numbers. So either one of those works. And that's the same thing that's going to happen kind of similarly with the cotangent. So the cotangent, the only difference is that the asymptotes this time, they happen at the multiples of pi instead of pi over 2. So these asymptotes are at minus pi, 0, pi, and they keep going. So the domain on the cotangent is all real numbers except the multiples, or I should say the integer multiples, right? The whole number multiples. So let me, except, whoops, still on a race. All real numbers except the integer multiples of pi. And the range on these, again, is from minus infinity to infinity. Okay, so the thing to recognize about cosecant and secant, and the way that I kind of remember them, is the secant, if you think about it, I could draw a little sine function going on in here, and what's happening is the secant is equal to 0 when the cosecant here, it's going to touch the graph of the sine function. So any place that the sine function has a max or a min, then the cosecant graph is going to come off of that. And any place the sine function was 0, so here or here or here, then the cosecant graph is going to have an asymptote. So writing out the domain and the range for this is similar to the tangent and the cotangent. So the domain here for the cosecant graph, so again, if you look, we want to look at where these asymptotes are happening. So it's happening at 0, it's happening at pi, it's happening here at minus pi. So it's the same domain and range as the cotangent. So it's all real numbers. I'm just going to abbreviate numbers, except the integer multiples of pi. And this time the range, if you notice, so remember I drew this green line in here, so I can take this green line out. So the range here is, there's nothing here in this middle piece, but it's everything else. So it's from minus infinity up to -1, and then we jump again back up to +1 and keep going to infinity. So the range is oops, be helpful if I did a parenthesis. So minus infinity to -1 union +1 to infinity. And secant is similar. It's just that the asymptotes on the secant go back to happening at those intervals of pi/2. So the domain is all real numbers except the integer multiples of pi/2. And the range is going to be the same as the range, on the cosecant. So it's going to be minus infinity to -1 union 1 to infinity. Keep hitting the page thing. 1 to infinity. So you just have to know what the graphs look like and be able to identify their domains and range. All the crazy transformations and all that stuff, we're only doing those to the sine and the cosine graph. We're not doing those to the other graphs as well. You could do them, we're just not going to.